Hello, mathematicians. In today's video, we'll be identifying linear and nonlinear functions from graphs. By the end of today's video, you should be able to say, I can determine if a function is linear or nonlinear from a graph. So linear functions, we've known, right, are straight lines, right? Because the rate of change between any two data points is going to be constant. So guess what? A nonlinear function is a function whose rates of change are not constant, and therefore the graphs are not straight lines, right? So over here we have linear, straight line. Nonlinear, not a straight line. So let's try identifying linear and nonlinear functions from graphs. Example 1. Determine whether the graph represents a linear or nonlinear function. Explain. So, is this graph a straight line with a constant rate of change? I would argue maybe it's two straight lines. But it's definitely not a constant rate of change, right? Because the left one is a negative slope, and on the right side you have a positive slope. So the answer is going to be no. So the function is nonlinear because the graph is not a straight line. And now it's time to check your understanding. Determine whether the graph represents a linear or nonlinear function. Explain. Well, I would argue this is not a straight line with a constant rate of change. It is in fact curvy, right? So this is going to be a non-linear function because it's not a line and it doesn't have a constant rate of change. Example 2. A square has side length of s inches. The area of the square is a function of the side length. Graph the function to determine if it is linear or nonlinear. Explain. All right, so squares, right? We're finding the area. So when you find the area of a square, right, you do length times width. But since it's a square, it's just the number times itself, right? So if this square had a side length of 1, it'd be 1 times 1, right? Which is 1. If it has a side length of 2, it'd be 2 times 2, which is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. So now I can graph the values from my table as if they were ordered pairs. So we'll say x is the side length and y is area. So side length 1, and I go up 1, which doesn't really exist, so I'm going to put it right there. Then we have a side length of 2 and a area of 2. A side length of 3 and an area of 9. A side length of 4, an area of 16. I'm not convinced this is very straight. 5 side length, and you graph 25. Oh my goodness gracious. Okay, hold on. So you graph this carefully. There really isn't a straight line through these points, is it? I tried my best with a smooth curve. It's a little difficult. So do the points lie on a straight line? No. So that means the graph is non-linear because they're not in a line. And now it's time to check your understanding again. A cube has a side length of s meters. The volume of a cube is represented by the expression s cubed, because to find volume you do length times width times height, so you do s times s times s. The volume of a cube is a function on the side length. Does the situation represent a linear or nonlinear function? Explain. So for this situation, if you look, these points do not all lie on a straight line. So since there's not a constant rate of change and they don't all fall on the same line, that's gonna make this a nonlinear graph of a function. In this video, we determined if a function is linear or nonlinear from a graph.